Okay, this is the match moving class. Let's begin by reading in the footage. Press R to open a read node, or you can just drag it and drop it in. And since I have it opened in the Finder window here, I'm going to go ahead and do that. I'll drag this into the node graph and close that. And let's attach a viewer to it. So let's press 1, and it'll create a new viewer and attach it. So Nuke's going to default, when you drag it in, it's going to go ahead and default the frame range to this clip. So from 1 to 419, we can see 1 to 419. Again, if we hold the mouse over the node graph area and press S, it'll call up the project settings, which I'm dragging them over. They're opening on my main monitor. The reason that's happening is I'm using my second monitor because it's lower resolution and everything on the Nuke display is a little bigger, a little easier to see. So let's go ahead and change the full size format to HD 1080, which is full size format of this clip. And again, format does not matter in Nuke. This is just a suggestion for creating certain nodes. So if we go ahead and create a constant node, we can see that it defaults to the root format, and this is where you set the root format. So if we were to change that to change the resolution in this node. So 1080 HD. Another got you with the resolution is in the rotor node. It's clipping to the format. You can also put no clip in this node, but generally sometimes you'll roto something and then the mask won't appear in certain areas because the format is set to 2K and you're working on a 4K plate. So sometimes that can get you. So, okay, check the frame range, full size format. We'll check the frames per second of this clip. If we look in the metadata, we can see that it's 29.97. So let's go ahead and change that to 9.97. And we'll close that. And we'll close this. Now, we can see by these weird lines here that this is interlaced footage. I've done this without deinterlacing it, but if you would like to deinterlace it to get a little bit nicer picture, you can go down to the junk drawer here, which is, where's my junk drawer at? There's the junk drawer, and you go to all plugins and hit update, and then you go to deinterlace. Anyway, you can just hit tab and call it deinterlace node. There it is, deinterlace. So let's get a deinterlace node here and copy to group. Command Shift X. Let's take that out. And if we open up the group node and expose the group's interior with this S here, this exposes the inside of the group. We can see that we have an input, which is inputting, the arrow inputs into this, and it has field select. So this is selecting the odd field, and this is selecting the even field. And we need to change the format of this to HD 1080. And isn't that fascinating? Let's change this to HD 1080 as well. Boop. And let's close all this crap here. Close, 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 close. And then we have a dissolve, which is doing the 50% dissolve between the two. So, and then there's an output. So that's inside of this group node. And here it is. Let's go ahead and do interlace, just so we know what that's doing. And let's go ahead and drop a shuffle node in here. and flood the alpha channel with white. So now we have a solid alpha channel. Okay, now go ahead and look at that image. That looks a lot better than the interlaced mode. So let's go ahead and grab a camera tracker node. So let's grab from the 3D menu. Once you update all plugins, then you get a lot more node options. The first thing to do with the camera tracker is to generally you want to look through your footage and see if there's any motion in this footage that you might need to rotoscope out, to prevent the camera tracker from tracking things that are moving. But in this clip, there's nothing really moving except the camera, which is good. So on the first tab here, let's go ahead and set the camera motion to free camera, and it is an unknown lens. It is an unknown constant. We do not know the focal length. If we had an idea, we could put approximate constant, or we could put straight up known, but usually 50 is not exactly a 50, so it's usually good to put approximate constant. If we had a zoom lens, we could put in the unknown varying or approximate varying, and it would calculate the zoom. As far as the film back preset, we could, if we knew what we filmed on, for example, if we used a Canon 5D Mark II or 3, we could choose that as the film back. But in this case, the film back is unknown, so let's leave that, and we'll let this camera tracker assume it's a 35mm film back. And I mean, if I had to guess, I would say that this is a Sony 2/3 inch video, which would probably put it along. There's not really a 2/3 inch camera in here. Maybe the FS100U might be a 2/3 inch. I guess not. Anyway, most of these cameras are production cameras, so we'll just leave this at custom. And let's hop over here to the settings tab, and this will allow us to look at what our tracking is going to do. Let's go ahead and preview the features, and this is saying this is where I'm going to put tracking markers down on this frame and what I'm going to try to track. If we decrease the detection threshold, it'll put more trackers down, although it doesn't really need to do that in this case. The increase the detection threshold, it will take away trackers from points that it deems to be not good to track. So let's go ahead and leave that at 0.1. Refined feature location will cause these to snap to corners. So you can see that this snapped from the middle to this corner. So I'm just going to I'll leave that on. The minimum track length, if a track is shorter than 3 frames, it's going to get deleted. If the smoothness of the track is how it's moving compared to the other tracks. So if this is deemed to be not as smooth as the other tracks because it's moving inconsistent to their motion, it'll be deleted. The track threshold is how much difference it is from like the previous frame. So these things can be increased or decreased to change the way it tracks different frames. But generally the default settings are really good. Feature separation will, if all your trackers are grouping in one location, you can increase the feature separation to force them to track other areas of the frame. But generally, all of these default settings are pretty good. You don't even have to turn on the refined feature location. In fact, let's leave it off for this. The one thing I like to do is just increase the number of features that it tracks. And the reason I like to do that is because it allows you to get a track, a camera solve at the end that has what's called a lower projection error. So let's go back to the camera tracker tab now, and let's switch this to global. So we're looking at globals, and now you can set the range. We're going to track the whole range of the clip, and also if you had an alpha channel, and let me give you an example of this. Let's just draw a huge ellipse like this, and let's copy this in. So copy the alpha to the alpha. Okay, let's do this. Okay, where's my copy? There it is. So let's copy the alpha in here. So now we have a solid white alpha here, and we just copied this oval alpha in. Okay, and now let's go down here back to the camera tracker. Let's hop back over here and preview the features once again. And now if we set the mask to be source alpha, that means that it's going to take the alpha coming through the source tab here. See? So if we set it to be source alpha, it's going to remove all the tracks within that masked area. Now if we set it to be source inverted alpha, you guessed it, the tracks are only inside the mask. So that's one way you can, that is the way that you would mask off a moving object. Like say there was a helicopter in this shot, or if this was a shot of somebody walking and you needed to match move this shot, but you don't want to track the person who's walking, obviously. Alternatively, and less desirably, this is not how I would do this ever, but you could attach this to the mask input and then use the mask alpha or the inverted mask alpha. You can also use the mask luminance, and I guess the way you would do that is if you use the keyer, I'm sorry, not a copy, keyer node, if you use the keyer and maybe let's see, pull the key based off the red channel like that or something. Okay, let's just say like that. Then you could let's see, copy the red channel into the red channel, and then use the source mask luminance, perhaps inverted luminance. So you could use the luminance, a luminance channel. Maybe a shuffle would work better. In any case, I would just use a straight up roto it out, copy it into the alpha channel, and then use the source alpha as the mask. In this case, in fact, if it's a solid white alpha, it deletes all the points. So we'll leave that at none. So again, just bump the number of features up to 300, set unknown lanes, and set the mask if you want, and then just go ahead and hit track. Okay, so that should take about 2 minutes to run through the tracking cycle there. I just paused the video and refilled my ice water. So once it's tracked, let's just go ahead and scrub through. You can see that all of our tracking points are sticking really well. I should note this is an extremely easy shot to match move. You will come across shots that are more difficult than this. And you'll come across shots that are just this easy as well. So it's just after you hit track, just go ahead and hit solve, and then Nuke will bring up a progress window, which I keep my progress window down here. So it's going to go ahead and run through this and solve it real quick. Usually if this takes a really long time, that's a bad sign. It should solve it really quick. It's not going to take 5 minutes as it just indicated. So let's see here, 90%. Okay, so after you solve, it's usually a good time to save a project. So I'm going to hop over to my volumes tab and save this right on the root level of volume citations track. Stadium version 001, and hit save, and it gives it a name up here. Probably spelled that poorly. Oh well, I don't care. So now we have an error of 1.43. Now this is the reprojection error of how well this scene is being reprojected through the camera, and that's 1.43 pixels. So it could be 1.5 pixels off. The per frame error is about the same. So let's go ahead and try to correct that. So let's use all auto tracks. So let's hop to the auto track tab, and the way I like to do this is I like to make everything red, and then bring it back till about half of the points are green, or at least enough points to solve the camera. You know, and this is something that takes practice. How many, you know, licks does it take to get to the center of a Tootsie Roll? You know, it's like, how many tracks does it take to solve a shot? You know, it varies from shot to shot. In a Pixel Farms PF track, you know, you can solve a camera with as few as 6 tracking marks per frame. So let's go ahead and start by increasing the minimum track length. So we've increased that to 100, and there's tracks on there that are above 100 frames. So let's just go ahead and we'll decrease that down to something reasonable like 10, 11. That's pretty standard, I would say. So let's go ahead and decrease the max track error to 0. And as I said, everything's red, so let's start bringing the max track error back until, you know, there's a reasonable amount of tracks. So now we've reduced the max track error from, like, whatever was at 3.5 down to 1.5. So now the max error is at 1.84. You know, you can view these things up here. Here's the max track error. There we go. So here's the max track error per track. So let's go ahead and reduce this from 8.84 till everything's red, and let's start bringing it back. Until, you know, we got a fair amount of tracks that is enough to solve. So I want some tracks in the background and some tracks on the ground, and, you know, of course the stadium. So we basically cut the track in half there, the error in half. So we want to go ahead and refine the focal length, refine the camera's position, and refine the rotation. So let's go ahead and, you know, this is kind of weird, because we're not going to hit refine solve quite yet. Usually things work from top down, but let's go ahead and delete the unsolved, yes. Delete the rejected tracks, yes. So all the red tracks go away. Now let's go ahead and refine the solve. It's going to recalculate the camera's focal length, position, and rotation. It's going to reduce the solve error, which is also, you know, the reprojection error, down to 0.87. And for an HD track, you definitely want your reprojection error to be below 1 pixel. So now that we have an acceptable camera track, we can go ahead and do something useful with the camera tracker node, you know, besides solve the camera. So we can export several things. For now, let's go ahead and export a scene plus, which essentially is just going to create everything we need to get going. So let's go ahead and we'll hit create, but let me just point out that the link output is going to expression link everything to the camera tracker, so that if we make changes to the camera tracker, those changes are going to be passed down and reflected in these nodes that we create. So let's just hit create. Okay. And what we have created is a whole bunch of stuff. So first of all, let's just close this for a moment. First of all, Nuke has created a lens distortion node based off the tracking information and connected it to the source. So let's go ahead and look through the lens distortion node, and we can see we have an undistorted plate. So let's just go ahead and select this dot here and press 2 to cycle between these. So 1, 2, 1, 2, and that's the undistorted plate. So we can definitely use this distortion node. It's connected through the background, which generally is not what we want to do. So let's just disconnect that, and I'm going to move the camera over here. So we have a camera, and the camera is plugged into a scanline render node, and the scanline render is basically going to control how everything in this 3D world gets spit back out into 2D. There's a variety of settings, including the Z-blend mode, which blends things in depth, the anti-aliasing, the filter that's applied to resize things. There's overscan, which if we look through the scanline render, and let's just reattach it. Oh, and of course there's this point cloud, which is being rendered as points. If we reattach it to the actual, just the plate here, we can overscan it by 72 pixels. So there's an additional 72 pixels of overscan. And that is useful when used in conjunction with the lens distortion node. And of course it's created a point cloud. So that point cloud is not just points like this, it is actually points in 3D space. And we can look at that by holding our mouse over the viewer, pressing tab, and that's going to bring us into 3D land. And right out of the gate we can see that the camera is on the ground plane, and our stadium shot is tilted up at a maybe 45-degree angle. Looks like something out of San Andreas or something. So let's go ahead and fix that, because it's nice to lay out our scenes in ways that make sense. So let's open the camera tracker's properties, camera tracker, and let's go ahead and look through it again in 2D land. And let's go ahead and select some points by dragging around them, and then also shift selecting, shift, shift, shift. Well, I'm holding down shift and selecting. So what I'm doing is I'm selecting points that I know are on the ground. I'm not sure that is. I know that is, and that looks like it's on the top of a pole. It's reasonably close to the ground. That's a light right there. It's possibly the ground. These are definitely the ground though. So let's go ahead and right click on those points and say ground plane set to selected. So those are now the ground plane. So again, this is expression linked to the camera, and expression, and you know, the tracker is driving the point cloud. So let's go ahead and look back in 3D, and now we can see our stadium's been set to the ground. And we hold command down to orbit, and then we have a giant camera floating above it, and we can see the bowl of the stadium, and that looks pretty good, except that this camera is giant and the stadium is quite small. So let's address that next. So let's go back to looking through the camera tracker again. You have to have the viewer attached to the camera tracker to work with these camera tracker points. It will not work down here. You will not be able to select these points. You also, you know, maybe it works if you're upstream of it, but generally I've found that if my viewer has to be attached to the camera tracker for these things to work the way one would expect. So we have a football field here, and there's probably like some sidelines here, and we have this area here. So we could use a point right there maybe, because I bet they run out from the corners. So let's go ahead. I don't have a point right there. Maybe I do at a later spot. Yeah, kind of. Yeah, let's go ahead and use these two. Actually, no, let's not. Let's use this one, and let's create a user track. So I'm going to add a user track, and I'm going to put it right here. And then I'm just going to go forward one frame, forward one frame, forward one frame, forward one frame. Just keep going forward and moving that. If I wanted to do an auto track, I think I would have had to begin at the beginning of the clip. So just move that. So now, okay, so here's this auto track. So let's go ahead and update X, Y, and Z. So it should be solving the position of this track. Okay. So now let's back here. Okay, so now let's select this user track. Oops. So let's select this user track, and let's select this track here, and hold shift, select the user track. Okay, so I have these two. I'm going to go scene, add scale distance, and it adds a scale distance in between those. Because again, remember we're solving the weirdness of the giant camera. And if we go to the scene tab, we can see we have a scale distance which is set to 0.15. So let's hop over to the handy dandy internet here and look at dimensions of the football field, that, and here it is. It's 53.13 yards or 160 feet. So let's go feet to meters. Feet to meters. And 160 feet equals 48.786 meters. Let's just Command C, copy that, top back to nuke, and let's put that in. Command B, paste. Okay, so now we've set a scale distance into the football field there, and let's go back and look here, and now we can see that the camera is much smaller, and the football field size has updated. You know, the point cloud is updated in the viewer. You know, let's just do one more thing. Since I'm kind of a stickler for details, I'm going to go ahead and select this track right here. I'm going to right click on it again, go to ground plane. I'm going to say set origin. This is going to be the 000 point. And we use that to calculate the ground plane as well. So again, let's go back in, and now when we rotate over it, we can see now that this small center grid has been placed at the origin. And let's go ahead and just rotate our camera through here. And let's just do a little bit more refining to this layout. So let's go to the scene tab, and let's rotate the entire scene on the y-axis to make this just a little bit nicer. So if we could hold down Option and click in front of the y, we can start rotating it by one numerical value. If we rotate and click in front of the 1 of the 18, we can go up by tens. And if we click here, we can start going by decimals. So you can do a really nuanced really nuanced adjustments with the Option key. So that looks a little better. So our camera starts facing down the x-axis and then rotates all the way around almost 90 degrees, or almost almost a 45-degree rotation to the z-axis. Okay, so there's our scene in 3D.